So let me introduce us to the use of Epanet software for modeling. The software name is Epanet, developed by the US Environmental Protection Agency more than 30 years ago. It has become a baseline tool for modeling water distribution system. Like I said, modeling, we have done the design, you have gotten your pipe sizes, but now you want to put it in a computer interface so that you can easily change the parameters, you can easily change the boundary conditions, you can easily change the internal variables without necessarily starting from beginning. So Epanet is not going to do any design, but it is the value we have gotten from those tables, those 4 parameters that we have, is what we're going to put in Epanet. Then Epanet will now tell us where we are having issues and where we need corrections and amendments. So this video is just like this section will just be to introduce us to the basics, especially the interface and how to use them. So here, this is the normal computer interface, anytime, anywhere. You have the name bar, you have the menu bars, you have the standard toolbars. Then you have the toolbars. This is the toolbars. Like this one is called test. This one is the valve. Okay. This one is the tank. If you hover around it to get it there, this one is the pump. This one is the pipe. If you want to add pipe, you click this. This one is the tank. Then this one is the reservoir. This one is the node. The junction or node are the same thing. This one is full extent. This one is zoom in. This one is zoom out. This one is to pan. This one is to select region. This one is to select object. So these are the standard toolbars here. Then this place is called the map area. While here is called the browser. This is the browser. The browser has 2 tabs, the data browser and the map browser. This is the map browser and this is the data browser. As you can see, the data browser is empty until you add something to them. So this is the general interface. So here is your tools. You can move it here, look at it, it's your tools. You can move it around, or you just leave it where it is. These are your toolbars. So we're going to be doing one exercise that is embedded in the Epanet software, and this is the Epanet tutorial. So I'd like us to go through this tutorial, and I'm going to start that by drawing this network. I'm going to draw this network and then analyze it. So in this network, they've done the job for us by providing us with all the data we need. For instance, here on page 4, you can see the node and the elevation of each node, and then the demand in each node. So this is the node, this is the elevation, and this is the demand. Ideally, this is what you are supposed to do as an engineer, and that is what we have done earlier on in this class. So this is 2 parameters for the node parameters, for the node properties, the elevation and the demand. If you go further the page, you also see another 2 parameters, which are the pipe parameters. Here you have the length of each pipe, and you have the diameter of each pipe. So with the length of each pipe, with the diameter of each pipe, you now go to Epanet, you impute them, and then you run the model. Okay. For instance, now, the first thing you need to do is to digitization. Let us digitize our network. Let us plan our network. Let us do the layout. So look at this. This is a water source. It could be a reservoir, it could be anything. From the reservoir, you put a pump. This pump will pump water from the reservoir into the node system. So the node will flow. When it gets to node 3, it diverts to node 4. Some still goes to node 7. From node 4, it goes down to node 5. Some goes to node 7. From node 7, it goes to node 6. And then the water just interacts in itself. And then the tank is tank 8. Normally, this is not the usual way we put our things. We usually say from source to tank, from tank to network. But it all depends. What they simply did here was to save the size of this tank by pumping water straight into the network while the tank still gets filled up. So as soon as the tank gets filled up, they will just shut the pump. Then water will flow from the tank into the network. I think this is the kind of system they have in Niger State. And that's also the kind of system, they don't have that system in Abuja. In Abuja, the water first goes to the tank, then from the tank to the network. But in some cases, as you are pumping to the tank, people are also getting water. or even the individual reservoir in each house is also receiving water. So that is how it is. So here, this is Epanet. So I will come here, I'll click here. One thing about Epanet is that after clicking any of the tools, always go back and click select. So I'll come here, I'll click reservoir, and I'll place it here. But now you can see that reservoir does not have number. So I'll go to, just like every software, when you open every software, you go to default, you set your project default. So I'll go to default, project default. When I go to default, I will set labels. So in this case, this is the label my pipes are going to answer. I want all my junctions to answer J, my reservoir to answer reserve, my tank to answer tank, my pump to answer pump, my pump, my valve to answer valve. I'll go to properties. I'll set the elevation at 0. Later I can change them. The diameter, I'll change that. I'll raise that 10, and the height 5, and just set the parameters the way it is. Here, the diameter, I'll set it at 75. Okay, but being that we're following this tutorial was done in American unit, which is empirical. Okay, we're going to follow the empirical unit, American unit. Just stay with me. So here, it says, why I'm giving you this tutorial is that at the end of this training, you are free to go through this tutorial and then understand more how to use the Epanet. And within the week, I'll send a lot of videos. Please find time and watch these videos. It's as good as having an extra session, which we don't have that time. Okay, you can see some people have already, maybe they're waiting for other things. Well, it's supposed to be 15 in this class. Okay, now, if Epanet is not really running, say launch it, blah, 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 did a lot of things. He says on the ID page, set the prefix and set the increment to 1. Okay, default, we open the default. He says on the hydraulic page, choose gallons per minute as flow units and Hazen-Williams as head loss formula. So we'll go here. The ID, I make sure I set the increment at 1 because I've done it. Then under hydraulics, he said I should choose gallons per minute. That's what the Americans use. Gallons per minute. And then head loss formula. We have the Schiffersbach, we have Manning, and we have Hazen-Williams. So we're using Hazen-Williams. So I set the Hazen-Williams formula. And that's all. Oh, and then we should change, okay. So I'll choose okay. Then I'll go to view. No. He says setting the map option. He said next we'll set some map display option so that our ID labels will be displayed as objects are selected. So he said we should go to view. If we go to view, it will bring on the map option. He said select notation and everything. So I'll come here now. I'm trying to set my background so that I can know what I'm doing. So I'll go here. Then I'll go to options. View options. When I get to options, I'll set the node. So like the big, I'll set it to 5. Let's see. I'll go to link. I'll set it to say 2. Label. All the labels are okay, are checked. Then notation. I will select 4. I will say display node ID, display node value, display link ID, display link value. I'll go to symbol. Symbol is already selected, it's already checked. So I'll leave it the way it is. Then I'll go to flow arrow. Do I want the flow arrow? I can choose a flow arrow, I can ignore it. Doesn't depend, it doesn't mean anything. Then background. I want to choose a white background, black background. Me, I prefer white background. Okay. When I finish, I say okay. So you can see that it has labeled reservoir for me, but it also showed me that reservoir is still selected. So I'll go and select this black icon. Please, while using this software, always have the habit of selecting this black icon so that you can deselect everything you have selected. So I'm done with adding reservoir. The next thing I'm going to add the node. Look at the node. I'll add the first node here, J1. I'll add the second node here. I'll add another one here. I'll add another one here. I'm trying to draw that network you saw there. I'm done adding. I'll go and click the black icon. Next, I'll pick a tank. So I'm trying to digitize something like this. This is my goal. The next thing I'll do, I'll connect them with pipes. First of all, select them. I'll connect them with pipes. So here, if I click on one pipe, it will turn to something like a pencil. When I get to the other node, I'll click at the center of it. The pencil will disappear. It means I'm ready to draw another section of pipe. So I'll click here again. It will disappear. It means I have created P2 section, P3 section. No, it did not go. I'll redo it. Okay. I would have loved this to be a kind of a do as I do thing. So we are feeling digitizing now. So like I said, this is more like a simple way to digitize your network. After that, we now impute the values. For instance, we must have gotten the following values on page 4. So elevation, node 1 says elevation is 700 feet and the demand is 0. So I will go to elevation 1, double click on it. Under total head, I'll put 700. And elevation 2, node 2, elevation is also 700 and the demand is 0. So I'll go to this demand, this node, double click on it. Elevation is 700. In the case of the reservoir, you might not see elevation, but you see total head. Total head and elevation is the same thing. It's just that head is used for tanks, elevation is used for load. They all mean the same thing. It's simply meaning the height. And the demand here is what? 0. Once you put in any value, you press enter. The other node is node J3. So node 3 is 710, and the demand is 150 gallons per minute. So I'll go here, I'll double click it. Elevation is 710, just 10 different. That's why you need a pump. You need a pump to pump it. The demand is 150. Press enter. The next one is number 4, 700, 150. J4 is still at 700. However, the demand now is what? 150 gallons per minute. Those are those demands we got. Those are the 4 values we got. We're inputting them. The next one is node 6. And node 5 is 650 and the demand is 200. The other one is the 700, 150. And the other one is 700, I think. 0. Finally, the tank is 850. The reduction is 830. Or is it 830? So we have imputed 2 parameters for the node. The next is we have to go to impute another 2 parameters for the pipes. So the other 2 parameters for the pipes will now be 3,000 feet, 14 diameter for pipe 1. So this is pipe 1, because here is pump. So pipe 1, whatever value that is there, you can override it. You can override it. So here I say the length is 3,000 and the diameter is 14 inches. We are using inches because we are using American units. Let it just be the same with what we have, but in the real sense, you use a different thing. You can use a SI unit. And the next one is 5,012 in that order. Here, and the length is 5,000. And this one is 10. 7,000 and 10. So I have sized the whole pipe. If you notice, you see that the pipes, as we are moving towards the tank from the source, the pipe is decreasing, because at this point the pipe was about 14. But as soon as it comes to node 2, it will take water down, and then it will continue with a diameter of 12. When it comes to this place, another node 5 will draw some water down. It will now continue with node 10. So that's also good to tell you how these pipe sizes vary. As you move downwards, it tends to move. Tends to change. So the other ones is 8, 8, and 6. So it means this one is about 8. This one too is 8. This one is 8. This one is 6. 6 inches. So I've imputed the 2 parameters for the nodes, the 2 parameters for the pipes. I will now go and design my pump. If we open pump run with what we call pump curve. So the pump curve here is empty. So I'll close it. I'll come here. I'll go to curves. Is empty. I'll click add. So I can create a pump curve that will run on that pump. So this is 1. The pump ID is 1. The flow, I would say let the flow, the biggest flow I saw there was about 200. So let me say 200 gallons per minute. The head, how do I get the head? The tank is at elevation of 830 and the reservoir is at elevation of 700. So it means the total head in my system is 830 minus 700. So that is 130. So it means my tank is located at elevation 830, while my reservoir is at elevation 700. It means I need a pump to pump water to that tank. So the head I need is about 130, but I will just simply provide 150. Why am I providing 150? Because I need to give some allowance, I need to give some understand that there's going to be some losses in the pipe and losses on the hydraulic grid line. So I will say, okay, I'll go back to this pump again, and I'll under pump curve, I'll put 1. Remember when I created the pump, there was a pump ID called ID curve 1. So it means every time this pump wants to run, it will use that my pump curve I have created to model and to run simulation. Because what the software does is, number 1, it models, then number 2, it simulates. So after modeling, which this is a model now, this is a 2D model now, it will further simulate also a 2D. So after I've done that, if you go through the tutorial will tell you the next thing to do, but I know the next thing to do is just to run it. Okay. So I've added a pump curve. The next thing we do now is that we run it. So you come here, you say run. If there are errors, it will tell you. He said my tank has issue. He said the lower level of the tank is issue. So I'm yet to define my tank. So I should be able to come here and define this tank. Okay. So initial level could be 2, maximum level could be 8, minimum level should be like 1. And let the tank diameter be what? Let me first save my changes. I'm trying to save my work. Okay. I can't find my work. Okay. I saved it so I can open it again. Okay. So that is it. So I'll come here now, I'll run it. It says successful. If I want to view my result, I will now go to map. So for instance, I can view all the elevation against the diameters. Or I can look at the demand against the flow. So this will give you the flow at every point. At every point, this will give you the flow. This will give you the flow at every point. Then I can be able to see what is happening in my system. So the demand here is 0, demand here is 0, the demand here is 150, the demand here is 150, and so on and so on. So I can come here now, instead of viewing the demand, I'll say, let me view the head. You can see what the heads are. Okay. The head at the tank will be at 832. The head at the reservoir is 700, and the pump gave it more head. I can also go here and I will check it against velocity. Now, you will see how with this now, we know where my velocity is below 0.3. You can see all my velocity are okay. Here is 0.0 because this is a pump, so there's no velocity. But other places, my velocity are pretty okay. So as they are okay, it means, so visualization can be done with this Epanet, and it also helps you to see an overview of what you have done. Notice where you have issues and where you don't have issues. For instance, I can start to change this. I click it and it left me. When it left, what I'll just do is I'll go back here. I'll go to toolbar. And no, I'll go to Windows. Legend. And I'll bring it back. But if you lose any of your legend, and go to View. Go to Legends and bring it back. If you lose any of your windows, you can go here and bring it back. So I can keep on viewing different parameters. Maybe I'll build pressure. What's the pressure against flow? So this is based on what I put in here under view options. I told you to display 4 parameters for me: node ID, node values, link ID, link, and this other one. So that's why it's displaying all those things for me. Any questions, gentlemen? So please go to your WhatsApp. There's a 40 minutes video I have put there. So this gives you an understanding of how to use Epanet software, the very short tutorial I have just done.